Oh, phew, ammonia, powerful stuff. There's a smell that you'll never forget. Chemists in the 19th century spent a lot of time in the lab attempting to make this pungent gas directly from its elements, and they succeeded. The problem was the yields of ammonia were very low. They could not make significant quantities of the gas. In the early 20th century, Fritz Haber was working on the problem of how to increase the ammonia yield. He discovered that if the system in which ammonia was produced was warmed up and squeezed by intense pressure in the presence of an iron catalyst, the yield would increase. Let's consider some of Haber's data. He and his students made many measurements of the concentrations of ammonia present at equilibrium. For example, at 300 degrees Celsius and 300 atmospheres of pressure, that's 300 times the pressure at sea level, the percentage of ammonia in the equilibrium system is about 71%. They found at a too high of temperature, given the same pressure, the ammonia tended to break down into hydrogen gas and nitrogen gas. This reduced the concentration of ammonia present in the system. For example, at the same 300 atmospheres of pressure, but at 700 degrees Celsius, the percentage of ammonia in the system dropped from the previous 71% to about 7.3%. After repeated experimentation, it seemed like the best combination of temperature and pressure was a moderate temperature but a high pressure. At only 200 degrees Celsius and a whopping 1,000 atmospheres of pressure, the percentage of ammonia rose to 98%. These different percentages indicate that the quantity of ammonia at equilibrium could vary a lot, depending on temperature and pressure. But a pattern can be seen in this equilibrium and others. This pattern is what we'll examine in detail in a moment. But first, a use for ammonia that will really clear out your sinuses.